So, let's start over. We have two things that we're going to compare, time and distance. So we can imagine a car. At 0 seconds, the car has traveled 0 meters. 1 second, it's traveled 2 meters. At 3 seconds, it's traveled 18 meters, and so on. Okay, so we can imagine that we're basically taking measurements of this car as it's moving. Okay, so that's how this is working. So we need to, in order to understand, because this is just a bunch of numbers, we need to be able to put it on a graph to be able to see, like, well, visually, what does that look like? Right? We're just trying to visualize and see the numbers. So we said, so we have this big graph, and the first thing we want to do is make sure that we whatever data we have, we want to fill up the whole graph, right? We want to fill up the whole graph. Okay, that's our scale. Scale tells you how big or small your data is. So we have to do a little calculation for our to figure out our scale. Now, before we do that, though, let's talk real quick. How do I know which one of these is going on my x-axis versus my y-axis? There was a thing that I told you. Do you remember? Time almost always goes on the x-axis. Almost. I won't say always because there'll be exceptions. But almost always, time's going to go on your x-axis. And that's because time is, if you remember the term I used, the independent variable. Okay, that's the thing that I'm controlling. I can control at what time I'm taking a measurement. I want to see what is the effect of time on the distance. How is the distance changing as the time progresses? So this is what we call our dependent variable, because it's basically, this is what we're measuring. We're just measuring the distance at specific time intervals. Okay, so that means that time, we're going to go, I'll just go ahead and write here, time's going to go on our x-axis. Okay. Oh, sorry, I'll write in pen because I know sometimes it doesn't always show up. And if it's dark, remember, this is the first time I've used this thing, so if it's dark or you need me to zoom in, right, like that, a little better. So we'll just focus on time first. Okay, so time's going to go on our x-axis. So let's try to remember our steps for scale. So first thing is we have to figure out the range, the scale range. So that's telling us how high and how low does our data go for time. So what's our highest value of time? Of time?
Oh,
10. 10. Okay, so we have 10. And our lowest value of time? 0. So we're going to subtract 10 minus 0 equals 10. So that tells us that we need to be able to fit and stretch 10 data values all the way out across our graph. So next step, we got to count the squares. So count how many squares do we have all the way across our graph. Some of you already counted. How many was it? 20. Okay, so we have 20 squares. So we're going to take the 10 and we want to divide by 20 because we're taking our 10 data and we're chopping it up into 20 pieces. 10 divided by 20 is 1/2. 20 divided by 10 would be 2. 10 divided by 20 is 1/2. Okay, 10 divided by 1. So that tells me that each box will have a value of 0.5 in order to get from 0 to 10 all the way across. Okay, so 0.5, here okay. So we're going to start at 0 on our x-axis. Now here's the trick, right? We have a lot of lines. If I put every single value on here, it's going to get really cramped, right? So I'll do the first couple just so that we can see. So the first line is going to be 0.5 and then 1. Right? We're going up by half steps. 1.5, then 2. Okay, but that's going to get messy. So we're going to skip lines. So 2, 2.5 would be there. We're going to go to 3. 3.5 would be there to 4. And you should end with 10 on the very end. Okay, now let's do our other axis. So our other axis. So now we're going to measure distance. What's our high value? 200. What's our low value? 0 equals 200. How many boxes do we have going up? 20. There's 20 boxes. So we're going to divide 200 into 20 little pieces. So 200 divided by 20 equals 10. Oop. So each box is going to have a value of 10 on your y-axis. Make sure you pause me if you're lost or if you're like not sure why I did something, okay? So again, we go down to our y-axis. We're going to start with 0. The first number is 10, 20, 30, 40. Again, it's going to get a little crowded, so we can skip if we want. You don't have to skip, but, you know, it makes it look a little bit nicer. So 40, I'm not going to do 50. I'm going to put 60, 70, 80, 90, 100, and so on. And you should end up with 200 at the very top. Let's try it the other way. I'm curious. I'm gonna will it switch? It's not switching. Is it switching? Oh, because I'm recording. Dang it. It won't let me switch aspect. All right, we'll just stick with this. All right, sorry all you folks at home playing with the camera. Okay, so there we go. So now we have our X and our Y axis set up properly. Okay, so that's our scale. Our next one is units. Do we have our units placed properly? They should be. Looks proper, right? L, labels. Do I have labels? Not yet. Okay, so we said our x-axis, we're going to write time in seconds. Remember, you always have to have the unit of measure. Okay. Then our y-axis is going to be, I'm going to turn it sideways, distance in meters. I'm going to abbreviate meters. All right, so are we going to need a legend? We don't need a legend because we're only comparing two things. If we were comparing a third and we ended up with 2 lines, then yeah, we would need a legend, but we don't. And we'll come back and visit that. All right, title. Uh-oh, we need a title. So, nope, that's not the title of our graph. The title needs to be specific to the data that we're using. So the easiest way for a title is we can say graph of distance versus time, because those are the two things that we're comparing. Excuse me. Okay, there's our title. Accuracy. All right, now we need to actually put them onto the graph. So these are X and Y coordinates, just like you do in your math class, okay? So we're gonna start with 0x, 0y. So on here we say, here's 0x, 0y. We're basically at our origin, right? The next one is 1 and 2. So we come over to 1 for the x, and we go up to 2, which is just above the line, right? Because the first line is 10. So we're just sticking down here to 2. Then 2 and 8. So 2 and then 8, almost up to 10. Here, let's do this. Is the red doesn't really show up any better. And keep going. 3 and 18. Okay. You can double check your points that they match up with mine. Right, so that's your accuracy, that you put them in the right place. N is neatness. If you make mistakes, please erase them, clean it up. And then let's go back to scale. Now that we have our data on there, if we think back to scale, does our data stretch across the entire graph? Yeah, it goes as high as it can, it goes as low as it can, it goes as left as it can, it goes as right as it can. So we have filled up this graph with our data so that we have a good we have a good scale. And so we've done everything, right? We got scale, units, labels, title, accuracy, and neatness. And there you go. You made your first graph in biology. By the way, the other science classes use the exact same method. Even the AP science classes use the same method. Okay, so you guys are using something you're going to use this throughout your high school career. And it'll come in really handy in college. Even if they don't say Sultan specifically, you'll already know how to make a good graph. And you know what? I was just talking to Miss King next door or across the hall. She teaches AP Environmental Science, and she's teaching that to them this week with slightly more complicated data, but she was surprised how many. She's like, how many of you seniors all can make a graph from scratch? And they're like, oh yeah, and like half of them were all wrong. Okay, yeah. So it's a skill that you need. Okay, so she had to really step back like we're doing and make sure to teach them, because they have to be able to do this on an AP test in order to get credit. Okay, and some of you will take that class, I'm sure. It's a good class too. It's really interesting. And there we go. Okay, so that is that one. At the end of class, just drop that in the basket for me. Okay, that show me that you did that. All right, you'll get. But let's go ahead and we'll switch to the little graph, to the little page. Right, yeah, we didn't need a legend on this one. We didn't need a legend because we only have one series of data. If we had more than one series, then we would have to have a legend. All right, so let's look at this one. Okay, so this one's kind of nice because it's got a little extra notes for you in case you to help us remember. So graphing is an important procedure used by scientists to display the data that is collected during a controlled experiment. There are three main types of graphs. Pie circle graphs. So like yesterday, so this is used to show parts of a whole. So yesterday when we did, or the other day, we did a pie graph. And so basically this is all of our data is all within that circle, and we just chopped it up into wedges. And so, and this is but representing a portion out of 100%, out of everything, okay, out of the whole. So if that's the way that your data is presented, then that's when you would use a pie chart. Bar graphs are used to compare amounts of something, counting. So for instance here, this was amounts of students taking biology and chemistry and physics, etc. Okay, this bar graph was amounts. And line graphs are used to show the change of one piece of information as it relates to another. That's what we just did, right? We were comparing how does distance change relative to time, right? We're comparing those two. So that's when we use a line graph, or what we might call a scatter plot, because these can be scattered all in a row, all over the graph, okay? Okay, both bar and line graphs have an x-axis and a y-axis. All right, parts of a graph. Title, right? So this is a worksheet that is, is unrelated directly to Sultan, but still has, you'll see, right, similar stuff. So of course we know that we need a title. The independent variable, again, that's the thing that's controlled when we're doing our measurements. Notice it says such as time or dates. And independent always on the x-axis. We'll work with independent and dependent later, but I wanted to get to the graphing first. Okay, Dependent variable, that's the thing that's measured. That's the thing that's affected. So like this one, as time was going by, the distance was affected. Okay, so that goes on your y-axis, is your dependent. And then of course the scale, right? The scale. In constructing a graph, one needs to know where to plot the points representing the data. In order to do this, a scale must be employed to include all the data points. We want to get everything on the graph and fill up as much space as we can. All right, so number A, we're going to graph the following information in a bar graph. Label and number the x and y axis appropriately. So we're going to make a bar graph first, even though we did just do a line or scatter plot. Okay, so let's see. So we're going to use, in a bar graph, oftentimes, whatever your categories are, that's what's going to go on your x-axis. So we're going to put our months on our x-axis here, because we can see we are measuring the number of deer in each month. How many months do we have, though? 1, 2, 3, 4, 5, 6 months, right? We're measuring 6 months. Okay, so we still got to figure out how big are our bars going to be. We need a scale for that. So we have 6 months, and we need to spread them out across, I'll just tell you this is 20 boxes. 20 divided by 6. What's 20 divided by 6? It's like 3.3. Okay, so we're gonna, for this case, we gotta decide how much, how wide our bars are gonna be. So we need to, basically we need to make, each bar is gonna be 3 boxes wide. We can't go to 4 because if we round up to 4, we'll actually outstretch it. So don't, for a bar graph's a little bit different for the scale, okay? So for this one, so we're gonna do 3. So let's just mark down 1, 2, 3, and just put a little tally mark. 1, 2, 3, 1, 2, 3, 1, 2, 3, 3. Okay, then we can label our months. So we can just, for each one, we're gonna do September, October, November, December, January, February. See if I can spell. Okay, but now the more important one is our y-axis, of course, right? Our y-axis. So on our y-axis, now we need to figure out our scale. What is our highest value? 38, right? 38. Okay, now here's the thing with bar graphs. Bar graphs pretty much always have to start at 0. So this is always going to be 0 on a bar graph. So, but we need it to go up to 38. So we're going to say 38 minus 0 equals 38. 38 divided by 20 going up. Anyone? I don't remember what it is offhand. Anybody do it in their head? Already got it? 38 divided by 20. Thank you. 1.9. 1.9. 1.9. All right. But we don't want to do 1.9, 3.8, 5.7. We don't want to do all that, right? We want nice, easy numbers. What are we going to round this up to? 2. All right, we're going to round up to 2. Okay, so that means each box going up our y-axis is going to be worth 2. That's going to get crowded since we have them all close together, so I'm going to skip. Right, so the first one would be 2. I'm going to put 4 on the second one. 6 and 8. 10 and 12. And you should end up with 40 right at the top. All right, so there's our scale. We got our scale, we got our units. What's next? Labels. Oh, we got to label our axes. Labels. So x-axis is labeled month. And by the way, this is the first time I've used this particular worksheet, and we're not really going to worry about the questions over here because we're just doing it. If I had thought ahead, I would have gotten rid of all these lines. So just ignore the lines for these questions over here. We're just focusing on the graph. So month on the x-axis, and we're going to turn it and put number of deer for our y-axis. And there we go, right? Now we are ready to get our data on there. So for each one, remember it's three points, 3 wide. So for September, we're gonna go up to 38. So September, find 38 up here, make a line up here, a bar over here, and we're literally just going to make a bar. So we're gonna follow it all the way down. And then we can even color it in. Right? Bars are usually colored in. So there's our 38 for September. Okay, October is 32. So find 32, make a 3-box line, bring it down. Okay, 26. If you want to get fancy, you're always welcome to add color. December is 20. January is a little bit awkward because it's in between 2 boxes. 15. And then February is 12. All right, we got the scale, got the units, labels. Oh, what did we miss? What did I forget? What's missing from my graph?
The title.
A title. I do not have a title. Number of deer per month. So we must have somebody going out and counting the deer out in their field every month. Something like that. You could say versus month. You could say, there's different ways of saying it. Again, not everybody's graph is going to be exactly the same. They should be pretty close, but it doesn't have to be exactly. But there we go, right? Accuracy, I got my data in there. Nice and neat. When you're doing yours, to make it neat, I know some of us like to use rulers or a straight edge to make everything look nice. Definitely a good idea. Any problems? Okay, let's go to the back. And let's make a couple line graphs, right? Because these are the ones that are more interesting and a little bit, takes a little extra. All right, so let's see. So we're measuring number of days and number of bacteria. All right, so this scientist must have some petri dishes and they're trying to grow some bacteria colonies. And they stick it inside an incubator, and after 1 day, they pull it out and they put it under the microscope and they count how many bacteria they have. They stick it back in. Then the next day, they pull it back out and they count. right? That's basically what's happening here. So which one of these is going to be our x-axis? What do you think? Yeah, probably the days, because remember the time I said is almost always going to be our x-axis. So this is going to be our x. So that means number of bacteria, because that's the thing that we're measuring. That's going to be our y. So number of days, what's our high value? 6. Low value? 1. 6 minus 1 equals 5. Same number of 20 boxes, so 5 divided by 20 equals, do we know? 0.25, or, right, same thing as 1/4. So that tells us each box on our x-axis, each line is going to be 1/4. But again, we don't need to label every single one. We can skip. How are we going to do that? Well, let's see. So our starting point, we're starting at 1 on this one. We're going to start at 1. And then let's think about this carefully. The first line is going to be 1 1/4, 1 1/2, 1 3/4, 2. So you're skipping 4 to get to the next whole number. From 2, we go 2 1/4, 2 1/2, 2 3/4, 3. At this point, we can just count. 1, 2, 3, 4. 1, 2, 3, 5. 1, 2, 3. And now we have 1 through 6, all the way to the ends of our axes. Nicely, oh yeah, and that, remember we said evenly spaced. Evenly spaced. Okay. Y-axis, number of bacteria, high value, 200. Low value, 4. One, 196. All right, 196 divided by 20. 196 divided by 20. 9.8. Not a very nice even number, is it? What are we going to round it to? 10. That's going to go to 10. So every box on our y-axis is worth 10. So again, I'm going to skip, right? The first one would be 10. But for neatness, I'm going to go up to 20. And that's where I'm going to label it. We're going to start at 0 for this one. 20. Let's see. 30. Yeah, 10, 30, 40, 60, and you kind of have to, whew, my old eyes are fooling me. 80. And so you should end up with 200 right up at the top. So there's our scale, there's our units. Labels. Don't forget our labels. We're just going to pretend that these lines aren't here, and I'm going to add a label. Number of days. And turn it over. Number of bacteria. We don't need a legend because we're just comparing the two things, or the one thing. Title. We need a title. Number of bacteria. You could say per day or each day. or versus days. Wow, my spelling is really off. Per day. Or should we make it versus to make it easy? You do however you like, right? As long as you're comparing, as long as it's describing those two things that we're measuring. All right, accuracy. Now we're ready to put our data on. So 1, I'm going to go up to 4. Way down there. All right, got my scale, units, label, title, accurate, and nice and neat. This is where using pencil helps, right? So I should clean that up. But I'm using pen so that you guys can see. All right, there we go. Can we read all these numbers on the last one? 20, it looks like that's 20, that's 10. Our copy machine got really dirty. I don't know what happened. That's a 10. Okay, so last one. Let's have you guys do it. Go through the steps. Let's see if everybody comes up with the same graph. Go for it. All of you following along at home, you're going to work on this yourself, and then we're going to check it in just a bit.